Now let's consider this example. Let's say 7 candidates are applying for a contest and 7 jury members are evaluating the performance of each candidate. Based on the average score, candidate 1 seems to have obtained the highest scores, and he got the least one. So we can anyway calculate the mean scores of 7 jury members. So we add all and then divide through 7, so number of jury members. But perhaps some of you might be curious whether these numbers are really representing the agreement of 7 jury members, or is it happened by chance, which means whether there was a concordance between jury members. For this kind of a situation, you can use Kendall's W test. Kendall's W test is used in order to measure the internal consistency of more than 2 related data. It is applicable for both parametric and non-parametric data. And it is very practical to assess the agreement among raters. Imagine that you have provided several design items to a group of design people and let them rank the products, the designs, in order of their preference. And they will anyway answer. And you will get anyway the mean ranks. But you are not yet sure whether the mean ranks is really representing. In other words, whether there was a really concordance or agreement between the rating people. So, as we learned, the Pearson correlation coefficient R assumes the normal distribution. And the Pearson correlation analysis actually only compared 2 sequences of outcomes at a time. But Kendall's W makes no assumption regarding the nature of the probability distribution, and Kendall's W can handle any number of distinct outcomes. And Kendall's W is linearly related to the mean value of Spearman's rank correlation coefficients between all pairs of the rankings over which it is calculated. The Kendall's W ranges between 0 and 1. 0 indicates no agreement. 1 indicates complete agreement. So when W is 1 or closer to 1, then each respondent, in former case, each jury member had assigned the same order or very similar ratings or same ratings to the list of concerns or list of the people or the candidates in previous case. But when W equals to 0 or when W is close to 0, you can conclude that there is no overall trend of agreement among the respondents or among the jury members. Their responses may be regarded as random. And if you perform the Kendall's W test, you will get the significant test significance value as well. So now we are in SPSS, and let's perform the Kendall's W test. Non-parametric analysis and related K number of samples. And Kendall's W, okay. So here we are presented with the mean ranks of 6 candidates, and they were evaluated by 7 juries, and the Kendall's W is 0.37, so it belongs to the medium size of coefficients. We can roughly interpret the size of effect in referring to the way we do for correlation coefficients, such as R or rho. But because this situation is about whether the juries have had the agreement or concordance, so when they really made a correct judgment or where there was a really clear distinction between candidates, by convention, it is more likely to expect that there should have been a strong agreement. But contrary to our expectation, this W value is, in my personal opinion, relatively small. So it doesn't sound very plausible to conclude that there was a strong agreement or even a medium size of agreement. Therefore, if you have to select the first ranked person, then obviously candidate 1 will be the person. But if this is the case of like showing the agreement of design preference, then if your W value is in such a value, then although your design A is preferred by or evaluated higher than the other designs, but you still cannot draw conclusion that that's based on the very high or robust concordance between raters or evaluating people.